This is a bit of anger. So this is billed as DJ's talk, but really I've given this a whole bunch, and I wasn't supposed to be here, but now I'm here. So I'm going to do the first part, and then when we come out of the demo, we'll bring DJ on as we open it up to more discussion. He's much smarter than I am. I'm just really good at this particular presentation. All right, so with that, I'd like to start this with just a little reminder that this has been on the OWASP top 10 for over 6 years now. And I've just this year have really been coming back to this. We used to talk about this a lot 4 years ago when I first joined SonoType. And just so you know, before that, I was at a couple of Fortune 100 insurance companies where I was a practitioner and I was, doing build and release management and starting DevOps initiatives. So I've walked. But it's been out there for a while. And so before I go any further, though, how many people in the room identify as a security professional? See, I love this. By adding sec into DevSecOps, I feel like we get security. How many folks in the room identify as a developer? So that's good. There could be some more. And then the rest of you QA or management or some other function, right? All right. So I just like to remind this. And for me, this was a memorable day. So back, it was June of 2013 when this came out. But it's been there for a long time. And yet, in our most recent State of the DevSecOps Community Report, where we got input from over 5,000 folks, we still see that 62% of the organizations out there don't even have an open source governance policy. And so this year, I'm just going to ask everybody I meet, why? Do you have one? And if not, why do you not have one? This is my mission this year. And I should highlight that although in 19, I have data in here from the 18 and the 19 report. So if you think you caught me, it's just because there's two different numbers. In 19, it's actually 24% self-identified said they were thought they were breached as a known open source component, which was up 70% from 2014, where only about 14% of the people identified that they thought they had been breached for the same thing. And then the last bit at the beginning, though, is that your apps are made up of 80% of these things. So this is probably, if you're a security professional in the room, this might be a bit of a new bit of information to you, that the apps your developers are producing are made up majority of components they borrowed, right? We think about the code they wrote. We think about static code analysis. We think, dynamic testing is going to go test that whole app. But we aren't obviously taking the time to simply identify what's in our apps and have the information at our fingertips and what we know about those components to address that A9, right? The A9 says if it's known vulnerable, stop using it. But what we do know, thanks to this conference, which I've had the pleasure of attending every year since it began down at the airport, where there was 300 of us in year one back in 2014, I think. 2013 or 14 was the first year. But since that time, we know from our report that 47% of the respondents to that survey are now at a point where they're deploying multiple times a week. So that's really exciting. And if so who in the room thinks they can deploy multiple times a week? So it's not 47% of this group, but we have some folks in here. So that's good news. Good news for you is you're moving fast enough to have a chance in the problem we're about to present. If you did not raise your hand, you're going to need to speed up just to begin to address this problem properly. So back to those numbers, open source governance. This drives me, so we had folks identify themselves if they thought they were a mature practice or not. So again, self-identified. But I found it interesting that only 62% of the self-identified mature practices have an open source governance policy. So my retort is you're not as mature as you think you are if you don't have this one basic concept in there. But they're probably doing, there's 100 things we need to do, and they're probably doing, 95 of them, so they think of themselves as mature. And so this is that 24% number that doesn't jive with the other slide, but we know that the self-reported attacks on this vector has been going up, and it comes as no surprise if you consider that over half the organizations out there aren't even looking at this information, which means it's flowing into your apps, and it's out there in production facing the web. And there's all, the thing I like to point out about the A9 is it encompasses several of the other attack vectors of the other top 10. So you can inherit cross-site scripting. You can inherit remote code execution. You can inherit other OWASP vulnerabilities through that one subcategory, right? So these often lead to really bad things. The other thing that coincides with this. So not only we have this big problem, we're not proactively doing anything about it for the most part, despite it being 6 years old. What I like to point out is the bad guys are doing DevOps better than we are. Which is to say, the minute there's a responsible disclosure on a security vulnerability, they're in a position to turn around and exploit and attack you within 3 days. So many of you did not raise your hands that you could release every 3 days. They can, right? And in fact, for the NSA has reported they often see stuff within 24 hours. So they are turning around and weaponizing these things much faster than we can get our own software out. So that's the tension I'm talking about. We're going to have to get to where we can automate faster than them, or at least as fast to keep up. So this is a big change of this, is where we've got 3 days from the time it's been announced to the time you could effectively be attacked. Combine that with the fact that, and so again, 18 numbers were 15,000, but in 19 it went up to 21,000 new releases every day. So every day there's 21,000 new open source components available for your developers to use. That's just an overwhelming amount, right? You can't even begin to wrap your head around it. Even if you started one day, you would quickly be overwhelmed, certainly by lunch the next day. It's just too many, too fast. But we don't care about all of them. So here's some stats. This is something I just played around with recently over the weekend. We know that the average organization consumes over 300,000 open source components a year. We know that because we're the stewards of Maven Central. And so we see Maven Central's download reports, but we also talk to the folks at NPM, NuGet, and the other package systems. And so if you go to like module counts or someone, you can see that this is roughly, or module counts is the new stuff. But so when we aggregate all that data in the State of the Software Supply Chain report, we come up with an average number of 313,000, of which most companies are using about 8,200 component versions, which means it's which comes down to 2,778 individual components. So you're looking at an average of about 3 versions per component. Now these are all averages, so they're lies. Nobody's actually doing this, and most people have a lot more versions, and it skews in other dimensions. But what I thought about with this is, so that means in theory, you should be vetting, if you had some open source governance policy, you would need to vet 8,200 components a year on average. So let's do some math. Who here has an AppSec team of 15? Did your hand go up? Or there's not a single AppSec team of 15 people in here, right? Who thinks they're on the biggest AppSec team in here? Who's got a team of 5? Got a team of 5?
How about 3?
You got 10? So a team of 10, that's the biggest team here. How many do you support? 10,000 developers? What do you support? 5,000 developers? 200. You have a team of 10 supporting 200 developers. If these guys are hiring and you're an AppSec professional, you want to talk to this guy.
That's awesome.
I've never heard that ratio. I usually get about 1,000 to 1. One AppSec guy for about every 1,000 developers is usually what I'm hearing. But so if you don't have a team of 15, you can't even possibly begin to manually just process the flow of open source components coming into your organization. It's physically impossible. So this is why we want to turn to automation. So this was a blog post from 2017 from Susan Moore, and I'm pretty sure it came out in anger, because I think it's hyperbolic. I don't think it's actually accurate, but I think the anger was, given some of the things I just told you, given the sheer volume and variety of components, given the rise that we're seeing in attacks coming through this vector, given the fact that most organizations today still are not addressing this OWASP A9 concern, right? They don't have formal policies in place and with even a manual process, right? So that leads someone like Susan Moore to, in anger, say, by 2020, 99% of all exploits, vulnerable exploits, will be known by security at the time. That will have the knowledge of what the attack vector could be, only to watch it happen because we're incapable of stopping it, where we have it, or we're unable to act fast enough. I think it's hyperbolic, but it's interesting. It's interesting to think. So it's just a pessimistic view that says, given all the things I just described, this would seem like a likely future, because unless we change, this is what's going to happen. All right, so now I'm going to dive into the hands-on part that I'm going to do. But I just want to talk about, it's not a lot of demos and stuff are very contrived, right? They're very sort of packaged. For this one, what we did is shortly after the Equifax breach in March of 17, we went and found the REST showcase project and we forked it off. And we just took that little sample project and we threw it in a Tomcat container. But at the end of the day, that's a lot of what like your developers might be doing, right? They're just sort of taking, with something like struts, there's some reference example, maybe some project they previously worked on, starting with that as a base, building around it, deploying it out via Tomcat or what have you. So it is sort of real world in this, so even though it's an example project, it's very real world in the sense that this is the exact same way many of your developers might be bringing your apps into production. So this is the link, the Struts 2 RCE and the SonoType Nexus community on GitHub. This whole project's in there. I don't expect anyone to be able to kind of keep score here in the classroom, but if you want to, at a later time, revisit this, you're welcome to. And I'll have an email address at the end. I can send people the deck and some information if that would be helpful. All right. So this might be a bit of an eye chart. Eclipse is not great about changing fonts in my resolution. Let me see if I can. I'll just live with it. So this is the SonoType IQ server being integrated into an IDE server. And the reason we do this is to address this problem directly and direct it and solve it in a way that's putting this information right in the hands of the people that we think are in best position to help us solve this problem, which is the developers at the time of coding. Right? So when we talk about shift left and we talk about all that stuff, this is the moment that we have the opportunity to get it right the first time and not send a defect downstream. Right? The lean concept, like just do it right. Jez Humble talked about it. Gene Kim talked about it in the Phoenix project. It's an Edward Deming concept, right? So like, how do we just get this right? And the thing is, we felt, our theory at SonoType was, the reason people continue to use known vulnerable components is they're simply unaware. The developers have these components, but there's nobody giving them the information they need. If you have some manual ticketing process, they quickly stop doing that because it often takes weeks to get that approved, right? But that doesn't fit with our sprints, so you can't possibly like submit for a component and get it out in the same sprint. So what do? You stop submitting the ticket, you grab the component anyway, figure it's easier to get forgiveness than it is to get permission, and you move on. But we fundamentally believe that if we put this information in their hands at this moment, that we have an opportunity to deal with this. So this is the app, and the Struts core app that's in here is going to be our vulnerable component. And this is the kind of information we're presenting where we can see every other version available to us. And the colored bars underneath it represent whether or not there's a policy violation. So we've codified our policies as a set of rules, and then SonoType provides all the data. And so this thing makes a request off to our server, and it passes all this stuff back, and we get some good visibility into this. And the way we teach my entire developer training class is find a green bar with no red under it. You've all just been trained. It's really, really easy, but if you want to find a big green bar, that means that's in a version range that is probably API compatible. And if there's not at least a red, in this case there's orange, but there's no red, so orange is better than red. The idea with risk is not to get it to 0, but to get it down, right? And to know your risk, to quantify it. There are two things. One is to sort of suppress it, and the other one is just to quantify it. So let's take this project in the command line, and I sort of had to already build and package this stuff. So what's that?
You can make it bigger. Control Shift.
I made it bigger already. Can people see that?
Oh.
Yeah, okay. I was going to say, I thought I made it pretty big. So this is a pretty simple Maven clean, right? It has this rational application. It has a governance tool in the newer version, so if I don't have to skip, it'll fail because of licensing, so I've added that switch to keep that out of here. This talk is not about that, so we just try to avoid it. This should just go through really fast. Am I not on your Wi-Fi? What am I on? I'm on AT&T. Oh, this is... Where are you? Is yours on?
Nope.
It went through. Nice. Even though I'm on this free AT&T Wi-Fi, that's not at all sketchy. All right. I have my VPN on at least. All right, so you can build it, and then really what you want to do is you want to come back and you want to build it. And actually, in this case, I want to build... Right, I build an image called Hack Me. This might have been a bad idea. Is your hotspot? No, this is all right. And the other,
That's actually
it's going. Okay. Well, I already had everything cached, so it just kind of had to get through it. All right, and then what we want to do is we want to run this. All right, so I'm going to run it, and we'll just sort of confirm that real quick. So we see a new container showed up here. This is my app coming up. That one you can't see. It's awfully tight. Let's see if I can get this to... All right, so here's the app. It's up. It's got 3 orders in it. This is a sample REST application. And the attack vector actually wants to come through, it comes through these, and we'll take a closer look at that data in a minute, but this is exactly the URL we're going to attack. We could have done any order, but we just chose order 3. So to do that, now that it's running, I have an exploit that's in that GitHub repository. It's a Python package. And so here's what we're going to do. We're going to run this exploit Python. All the code's in there for you to look at it, and it's also sort of articulated in our data that we'll see in a little bit. But it's going to allow us to execute a command in this container, right? So if it wasn't a container, it'd be in your VM and your bare metal, wherever. But you just want to demonstrate that we can do this, right? So it told me I'm in the Tomcat folder, right? So I just proved a remote code execution in this, right? This is out there, it's known though. And I also at this moment like to point out, you know, it doesn't take a nation state to do this. I think in our minds, a lot of us think hacking is really hard, right? You have to be really smart. But the truth of the matter is, the teenager down the street, if he's invited into the right dark web, can download these attack kits and start to weaponize them, right? You don't really have to be this. I don't know how to do this, and I'm doing it, right? So what other commands could we run now that we're in here? What about the AppSec folks? You guys probably think better than the developers in terms of what we can run. What do I want to do now that I'm on your machine?
Nmap. Find out what's on the network and then pivot into it.
Yeah, there's a lot of great suggestions. I'm going to at least start with, I mean, the basic thing is enumerate, right? I want to find out who I am, what can I do? What have you given me so far? Oops, I typed it wrong, didn't I? How's that look? So this is a byproduct of the Tomcat container. If you do nothing to the Tomcat container, it's running as root. I'm not sure if devs in here know that. I don't know if AppSec people in here know that. Ideally, there's tools out there that would identify this when you run it. I think of Twistlock and Aquasec as being very good sort of runtime detectors. It's the sort of thing they would have pointed out to you. So this is not good. So from here, someone like DJ would just be salivating because now he knows all the ways to enumerate and all the ways to start to poke around your system, see what this thing's talking to, who's talking to it, where's the data. Or maybe I'm more interested in just mining cryptocurrency. Maybe I just want to get another payload down and start mining. There was a Litecoin conference here yesterday, so I'm going to go with Litecoin. Right? So this is the whole problem, right? Like this is just too easy, and it comes out within a matter of days of this being known. All right, we're all on the same page with that?
People as well take these vulnerabilities and they convert them and they start looking at what else this is running on. So if this is running inside of a Kubernetes cluster and it's an old cluster and you have some vulnerabilities, now I have root in a container. Now I can skip into the base underlying host, and then from there I can pivot into the rest of your network. So it's really serious. Like one of these vulnerabilities can be chained into other ones. Right. So this is where it's really serious.
No, absolutely. So I just catted the password file. Another target, I got to really stop doing that. Another big target would be look for keys, right? Amazon keys. That's another high-profile target. So now that I have this access, now that I have this, obviously we're limited only to our imagination. No, that's on my system now.
Oh, that's the shadow?
Yeah, you got to
do that. If you do the shadow, you'll get all the hashes for the password. You run them against a rainbow table, and
this one?
You'll have everyone's password. That's the shadow.
Does that look right?
Yep.
Right. So there you go. See, I just learned something.
Yeah, if there's any users in here, you'd see a hash of their password. So that's
all right. So that's the nature of the problem up front. Let's go ahead and I'm going to kill this container for now.
By the way, I got a really bad root password in that, if any.
Yeah, I'm sure. In the container, yeah. So now I want to dig deeper into this data. So here, like I said, as a developer, we were on 2.5.10. That's the version that's in here. I want to get up to probably at least 17 or higher, right? And so just in here, just as by way of example, I just want to show, if I go in here and just edit this to 20, and then this, I don't know how many folks know Maven, but struts projects, if set up properly in Maven, work like this, where I change the version in one place and it affects every struts component. So this version is actually calling out to the parent, which then has all the dependencies, right? Because you don't want it, struts, there's a lot of components in there, and you don't want to update the version of every one. If you're set up that way, what happens is they start updating the versions of some and not others, and now you've got another set of problems on your hand. But if I just update this to 20, which was what the recommendation was here, right? It will quickly, it'll basically update the dependencies, load them on the class path, we'll rescan them and reevaluate. See, unfortunately, so when I call my IQ server locally, it has to go hit our data services in the cloud, right? So we're not like a giant on-prem database that you have to maintain. This thing is constantly being updated in the cloud. It's just, there's a whole automatic vulnerability detection system that we have in front of our dedicated 70-person security research team. All right, so struts core is the offending thing here. And if we go dig into, actually the vulnerabilities and pull it up, I believe it is this one. So here's the kind of write-up we provide that's behind that data that produced that red or orange square, right? So we, right there at the front line, we want to dumb it down to something visual, something that's easily actionable, something you could just at a glance know what you need to do. I'm just looking for a new version. But in here, we give you the deep details of it. So there's the write-up that would have existed in the National Vulnerability Database, and then the next explanation comes from our dedicated security team, right? And so they have approached this very differently. We've tasked them to say, look, as you're doing this research and you're writing it up, I want you to write it up in a way that's really understandable by both developers, but also has enough information that an application security professional can really be a part of the process, right? Because and their two worlds don't always overlap well. So it's a bit of a challenge to come up with a write-up that makes sense for both. Now you get down into our recommendation, we talk about ways and workarounds. Even when there is no non-vulnerable version, we usually provide some kind of workaround or something that you can do if such information's out there. And we get all of that from, in this case, it looks like there's just an override of it, or of the class, which is typical. But in here, we also shared where we did our research, right? So we shared where we got that attack package from. That exploit pie probably came off of that link. And then this is where we got this information. We scored out with the attack vectors on the bottoms. Our guys actually always rescore it. So we look at, even if the National Vulnerability Database scored it, we will actually run it through the vectors ourselves and think with that deeper understanding. And maybe rescore it. And oftentimes we come out higher. We think it's actually riskier than was originally reported. Sometimes it comes out lower. But so it just depends. But what we're getting into here is a level of detail and precision that starts to let us automate. And that's what's going to drive all this, right? Without this precision, if we automate against data that's sort of mostly right, you get what you would expect out of it, right? Garbage in, garbage out. And then you get into alert fatigue. You don't want your scanning tool throwing tons of alerts, most of which don't mean anything. And I understand that from the application security community, you're sort of used to that, right? You're sort of used to static code analysis. You're making trade-offs like, how many rules do I want to run, which gives me the depth, but it's also going to produce more false positives, but it's also going to take longer to run. So do I do less rules, not go as deep, but maybe I miss some things, right? So this is a trade-off that I think the application security professional has learned to live with for a long time, but it doesn't have to apply in this world because we know, the components are components, they're hashed, we know if it's the exact same component. We've done the class level analysis of this, right? And so now when we see that component and it matches our hashes and our advanced fingerprinting, we can confidently alert you to whether or not it has a problem and feed that information to the developer and use it in your deployment pipeline to get better, to start to control it. So that's the data behind it that drives all this. All right, so I made one change, one version, but it's a little convenient because it's struts, so it has such a profound impact on the whole project. But if you're using struts, you likely see the same things. We're down to 3 now. There is no good version of the REST API, but if I was to go dig into that data, maybe there's a workaround, maybe there's something there that we can deal with. Jackson DataBind only just recently put out their first non-vulnerable release.
Yeah, that's been the bane.
That's been a back and forth for quite a while.
Resistance.
Although there's still some confusion on our data of whether or not it's shown up. But they finally took our advice and changed the default typing and input stuff, so they've avoided their deserialization issue. But so with that one change, we took a ton of risk off the table, got rid of a bunch of components because those struts components relied on other components. So things like Xstream are gone and other things are gone. So we're down to just a few. But the important thing is that one in particular is gone. And so now if I go run that, and instead of hack me, I have a fixed one, right? So I rebuilt it with the new version, recontainerized it. We don't need to watch all that. Let it come up running.
One of the things too is when you look at open source software scanning, it's really fast, right? And with those statistics that we saw earlier about the 2080, we've seen 3% to 15% to 20% of the software that is scanned by open source software components or any kind of DevSecOps scanners in the pipeline is code that you write. So a lot of folks actually set up a static analysis to scan all the open source components, and we'd be sitting here for the rest of the week probably waiting for that to happen. So that's not moving at the speed of DevOps, that's really jamming the wrong tool in for the wrong job. So when we're talking about DevSecOps and we see how fast this can get information back, that's going to be moving left.
So just to prove we fixed it, I'll go ahead and rerun the attack, and I get HTML back this time. I haven't popped a shell. I just did really what it's supposed to do and returned HTML. So the attack's gone, right? So we proved that it was there. We proved it was real and easy to get at. And we proved that just by changing our version number and rebuilding, the problem goes away. So that's that. So now let's go.
Can we automate that patching?
We're working on it. You know that.
See, that would be, yeah. I asked that question specifically because if you can have a zero-touch upgrade, and if you're deploying properly, then you can always roll back. It's sort of scary, but so is putting production code out there and getting another vulnerability like in the next 5 minutes. It comes up as a 0 day. So upgrade now, upgrade later. It's really risk of the organization, right?
So at SonoType we like to talk about, and this is the thing, it's an Edwards Deming concept. We all have supply chains. It's no different than the physical world. It's no different than the work that Demings brought to Japan, Toyota, Mitsubishi, and others that helped them really they took that work culture and it became a national culture that helped propel their economy to be the second biggest economy on the planet, rebuilding after the war, right? So it took a while, but they did using these concepts of building quality in. And the irony there is, we often think that if we take the time to write the test, if we take the time to do the extra things, we'll go slower, right? Because we're doing more things. But the reality is it increases productivity. You actually end up going faster because you take rework out of the system, right? If I fix this and I pass it down and you security folks do a scan and there's no issue, then there's no ticket, which means there's nothing for that developer to go pull off the queue to work on, and instead they're still writing tests, writing features, or doing experiments and trying to drive innovation, right? So the way your supply chain works is no different than anyone else, right? So things come in through your front door. We have a product called Firewall. I'm not here to pitch products so much, but there is a way you want to inspect these as they're coming in, right? And if they're not good, right then and there, stop them. And that can be really important because if your developer starts their experiment on a module and starts really building out a whole proof of concept or some minimal viable product, only to learn at the end of that cycle that what they were using wasn't acceptable, and maybe it's not a simple version, maybe they really want to change frameworks entirely or whatever that was, that could be a lot of work, right? We could end up churning a lot.
Even components that are coming in, you can tell that they're coming in. So for a security organization, knowing is half the battle, right? And if you can stop this at the gates and find out what's coming in, that starts getting you closer to knowing.
So a tool like this can save you 15 person years of work, right? And I did that math based on 4 hours of research. Our 70 guys, that's our holy grail. If we could get 2 issues per researcher per day, 4 hours, we think we've won. We're on a path of continuous improvement with that goal in mind. It often takes us it's usually between 4 and 12 hours, and this is all they do. This is all they do. This is their job every day, so they're as good and efficient at it as they can be, given the technology that we've empowered them with. But so this is right now, so does anyone have an open source governance policy and a manual approval? You do have some? Right. So that's a lot of hours that you have to invest just on that process. This takes all those hours off. Now, now what's my next problem? Okay, yeah, I bought my milk. It was good. I put it in the fridge. Now what's my problem? It's going to get old, right? It's going to go bad, right? Software ages like milk. It's not going to stay good. So we effectively have to ask ourselves every day about those 8,200 components, is it still good? Right? So we want to do that, and to do that, our lifecycle platform just is baked into the CI process and the delivery process. So as this thing's moving, it's always getting scanned. It gets the data of the moment, right? Because our cloud thing is being, since I started this talk, my hosted data service probably has 25 new vulnerabilities in it or something, right? Because they're just kind of constantly flowing into it. So you get the data of the moment. You can use this as an opportunity to automatically break a deployment process. We don't really recommend breaking builds. That just makes people angry. But not getting beyond QA, that's acceptable, right? It can be it an exit criteria or an entrance criteria. That's the appropriate place. Our repository product, which just stores all that. And so from here on, I want to just open it up to questions about this problem. If a lot of folks aren't doing it, anyone has any questions now, you can. But I want to dive a little deeper into how we curate this data, because that was the real challenge. It's one of the reasons this became an issue, is getting this kind of data isn't easy. It doesn't just readily exist out there, right? We had to build a team and become a data feed. We couldn't buy a feed. None of them were good enough. And the National Vulnerability Database is woefully inadequate. Let me see if I think I have some stats on the database. So here's what we do. Here's our view of it. And the way I like to simplify this, if any open source developer is talking about doing open source development on the internet, we're scraping that, running it through machine learning and AI processing, and that's how we're discovering these things. And it's in their Git commits, it's in their issue trackers, it's in their dev forums, it's in all those kinds of places. But then what's the missing step? What they're not doing is then turning around and self-reporting that off to the National Vulnerability Database. Right? That's an extra step that they would have to do, and that's where this falls down. And because they're not reporting that, we have about 1.3 million vulnerabilities that we know about that is not in the National Vulnerability Database. And to just give you an idea of how disproportionate that is, it's just in the last 8 months or so that the National Vulnerability Database added their 100,000th CVE. That's a fraction, right? And not all of those are open source. A lot of those are different platforms. There's infrastructure. There's a lot of different things in there. So that's where this all falls down, is that source is not reliable enough for us. And so we even did some benchmarking of our own. So we used the OWASP depth check, which relies on the National Vulnerability Database. And we did a scan of a bunch of apps, and then we scanned with our stuff, and we set it loose with our researchers, and we dug into it. And what we found is, if you're just using the National Vulnerability Database, you're looking at maybe getting 1 in 6 valid findings, right? And the reason for this, I don't have the CPE naming. I thought I had one more slide in here. The reason for this is the way this works is on a name match system, right? The National Vulnerability Database maps those CVEs to CPEs. CPE rolls up to something like Apache POI, Apache or struts, right? It just rolls up to a name like that, and all vulnerabilities are associated with it, but they're not associated with the specific component that brought it in, the actual class, the file that had the class that has the actual offending code. So they just lack the ability to make that association. So you're looking at a lot of false positives and a lot of false negatives if you're relying on this data. So like I said, this data just doesn't exist out there. So with that, are there any questions about this topic or any things that anyone wants to point out? Yes.
So let's say there's a team that develops an application
Our scans are fast, so we're not concerned about the time there. It's a good question, but we also want to know all the apps that are using Log4j, right? So one of the things I didn't touch on in this was incident response, right? So let's say we did everything really well, we got our nice clean app out in prod, and now we're facing a 0-day. How do you, so anyone in here now, did the last time you got a letter from the FBI, which is probably in the last year, right? Or if you're a financial services or whatever. But when was the last time you got a 0-day and you were able to immediately report the impact to your portfolio and say, oh, we know that this component is used in these apps? Anyone been able to do that? Yeah, see, right. And how do you tack that? Do you just ask teams? Do you run endpoint scanning? What do you do to answer that question? So the reason we do all those scanning is the simplified version is everyone's using Log4j, but the reality is they're all using different versions of Log4j. No two of them are the same, right? And we just need to know every app that's using every version of Log4j, so when new information comes along, we understand the impact, right? So that's our mean time to detection, and then we can work with that team to fix it, ideally in the next release, and ideally in less than 3 days, right? Ideally, for the nastiest ones, we have less than 3 days to get that patch into that app rebuilt and redeployed, or we're at risk.
Yeah, one of the problems with components is developers will pin them, right? Like if you look for a CocoaPods, or gemfile.lock or something like that, you're going to see a version in it and it's pinned. So it's not going to update. It's not like you're using the latest. So there's a few places where you got to put these kind of open source scans. You got to put them on the developer machine so they can do it while they're typing or find out there. But then when you're putting it to your build server and you're starting to run that automation, you got to do it again there, because by the time somebody checks it out or takes that component, they pin the version and then they put it through the pipeline. Maybe that's where you're pulling that in and finding out again, that there's a vulnerability. And the whole SBOM, or software bill of materials, comes out of that too. So you can see what versions are in there, what components you have, and the sub-components too, because it's like an iceberg. But
yeah, how frequently do you guys release software? Is it quarterly, monthly? You do release daily, so you raised your hand. Oh, so you're in a good position. Because that's what I was going to say, even from my early SCM, release frequency affects your thinking. If you only release once a quarter, it's important to rescan because it could be a month or two old since the last scan, right? But if you're actually really, really fast, it changes how we think about it because we just did it, and we just did it again, right? So we're in a much different situation than, in the insurance company, we have the end-of-year code freeze for the once-a-year release for open enrollment, right? That app goes out once a year. I mean, it's been staged and tested and stuff, but you really only got one shot at it coming around, but it's a long cycle. So if you did all your upfront work, it's old by the time you get to, September, when that's starting to kick in.
I always used to suggest scanning code that's been in a repository at least on a weekly basis so that you get ahead of it. Because, this is exactly the problem is you'll have code that's checked in with pinned versions, and then you'll pull it out and you'll deploy it. And if you bypass any of the security controls, there might be vulnerabilities in there because of the pinned version. So, keep scanning them regularly, even if they're in the repository, just to get that information ahead of the time.
So any other questions? I want to make sure everyone had a chance to poke at this.
When you say repository, talking against Nexus itself?
No, talking about GitHub, or pulling it out of your source control repository, because a lot of people just check it in and forget it. Or there's another problem too, where you have a team that has a fixed budget, they get put on a team, they create a product, and then they're taken off, and nobody will touch the product even though it's deployed. So that in that situation, there's nobody there to fix it. So that's another problem. But knowing that the component's in there and it's vulnerable, that's going to help you sort of prioritize. Hopefully you won't have the security organization pointing it back at you saying, you fix it, you fix it.
Is there a way to get a view of what's in Nexus as an example?
Yeah.
Yeah, the integration, I didn't show a ton of the platform, but the integration does in Nexus. So when you're in firewall, and even without it, even in our free product, you can get to,
So there's a lot of different things you can do. We set up a Docker proxy. So anything that came down, we'd know about it. And when you checked it in, it would check in locally. So that container or that image would be in the local image repository. So that just sort of helps get the information. And then we actually did a redirect. So if anyone called hub.docker.io, it went right to the repository. So you avoid all this.
So in our free product, we have repository health check, which does a free cursory scan of everything in that one repository. So that's out there for free. I think it's limited to public data only. But then Firewall gives you that more detailed report. Now this is based on the complete data set from the back end, the paid data set. Oh, actually, I can't log in as that account here. That's right. I'm a fool. I switched over. I can use it on the back end. I can't use it for the UI. But this is also a scan of the repository. So it looks like an application report, but it's a repository report.
This is your SBOM, your software bill of materials. See all the versions, see what it is.
Actually, that didn't go to it. Let me try one more.
You got a question as well?
Yeah, what type of scanners do you have? It looks like you might be looking at the Maven file to look there. Are you going into the containers themselves?
So you're talking about language support?
Yeah, well, no, we like to scan binaries. We like to scan as is, because when you scan against a manifest, and here's how I like to put it. If you show me your shopping list and you tell me you want to buy romaine lettuce, there's some bad romaine lettuce out there maybe, right? I don't know if you got it or not until it's in your cart. I need to see which romaine lettuce you got. And even if you say, I want this thing at this version, doesn't mean you got a genuine copy of it. So I want to check that you have a genuine copy that, and identify what you have. And I want to see it in the app. I don't want it, but having said that, our scanning technology is a mix. Not every language ecosystem lends itself to that. So with JavaScript and stuff, we're parsing JSONs. With Python, we're parsing a requirements text file, stuff like that, right? So you have to run a pip freeze or something, and then we work off of that file because the binaries aren't the same. Sir?
You're talking about the OS in general, right? Like the underlying base OS image?
How do you go deeper, right?
Okay.
As a developer, I'm pulling in these libraries, but say my Docker image,
Yeah.
I have a Tomcat one, and the vulnerabilities in that, or it's in the bash script.
It's both.
Right, so I have 3 tools that I like to talk about. We're not at a Red Hat conference, so I'm going to say Anchor. If I was at a Red Hat conference, I might say Claire. That's an OS level package, and it's a very different form of interrogation. You're actually interrogating the package manager in terms of what it's brought into the OS. Us for the application stack on top of it, and then Twistlock. So we give, the first 2 tools give you a complete bill of materials. Twistlock does Docker Workbench configuration. Aquasec's another one, right? So Twistlock or Aquasec I think is being relatively similar. But they do like configuration stuff, and they actually analyze the runtime. They can see if it was running as root. They can see who it's talking to. And then those can all be micro-segmented networks. So there's a lot of things. But those 3 tools in the world of containers, or those 3 types of tools, to be more fair, is what I think you need to do this well end-to-end, to answer all the kinds of questions that we're going to keep getting.
Well, just one other comment on that. When you're starting to look at the containers, you're also looking at the host, right? And you're looking at the runtime, and you also look at the tools. So I used to be a security architect at my previous company before I joined SonoType. And when we were looking at it, we got vendor images that would come in, and these would be part of our pipelines. Like we would put them into our production pipelines and we'd start running code through it. And they had more vulnerabilities than anything that we created. So then it comes to a problem like, now we can scan everything, not just the code that we make, but codes that our vendors make, code that assembles our pipelines together, and that's really important because now we're bringing in a Trojan horse. Really, we can have all these compensating controls till the cows come home, but having that internally. So yeah, you got to use something like the Twistlock, Anchor, or Falco, which would do host detection as well from Sysdig, something like that, because it's the whole stack.
You're going to want to stage them. You're going to bring them in, vet them, and then publish them to some, okay, this is a blessed kind of thing, right? Not that we are in favor of blessed repositories with open source components, but you do need some way to ingest, verify, and validate, and then make it available for use.
Yeah, I had a question about Docker images, and it seems like you basically answered that.
Okay.
We're talking that you have no problem scanning Docker images for vulnerability.
At the moment, yeah, the whole Docker world, I mean, first off, we all need to stop saying Docker because Docker's going away and it's getting replaced by other runtimes, other clients, right? So there's Kpax and Podman, and so we're making sure that my hope is if everybody stays within the OCI standard, it should still work, but we're trying to actively test some of that. So I don't want you to pin me to it just yet because there might be some cases where with Kpax that we can't scan yet.
Yeah, Docker's like saying Kleenex.
Right, right. It is like Kleenex now. All right, if that's it for the questions, I know you're at a big DevOps conference now, but I would be remiss if I didn't mention AllDay DevOps coming up, virtual online on the 6th. You're probably going to be drinking from a fire hose here for the next few days, for the last thing you want is another 150 talks. But the good news about this is if you sign up, even if you're satiated here, come New Year, you know, all these videos will be out there on YouTube and you can go back and revisit them. It's good content to have in your organization, to share with your peers, to start conversations, right? And all these talks are practitioner-led, so there's no vendor pitches, right? So it's all folks like yourself out there living and doing this, sharing their success, sharing their failures. There's 4 different tracks. So I just highly recommend it. You got nothing to lose. Sign up, get the links, have access to the content for the rest of the year. To take from here. Thank you everyone for coming out today and putting up with the whole initial setup.
Thank you.
Thank you.